Hello friends, now this is the second part of the video. First part I already completed. You just check it and rewind this. Okay. Now, previously we have studied about the scientific notation, right? A into 10 to the power of b. Now this is a continuation of it. Addition and subtraction in scientific notation. Okay. We need to add and subtract the numbers in scientific notation. Okay, what is scientific notation? Let us just focus at this point. Scientific notation is nothing but a into 10 to the power of b. Okay, scientific notation is a into 10 to the power of b, where a is the base and b is the order of magnitude. I previously told this. If you have any doubt, you just rewind the video. B is the order of magnitude, a is the base. Okay. Now, the a value should always be expressed between the values of 0 to 10. Okay, means 0 and 10 are not included. Okay, here is equal to is not there, it's just a inequality. Okay, a will always lie between 0 to 10, means the values will be from 0.111 something to 9.999, means it takes these many values. Okay, right, you need to not 0 also, not 0.1. So from 1 you can take it, means from 1.0 from 1.00001 you need to take till 9.9999. Okay, means you did not remember like this. Always the a should lie between 0 to 10. That's it. Okay, and the main rule behind addition and subtraction in scientific notation is that the power of the 10 must be same for the two numbers which you are adding. I'll give the example, but you need to remember this rule, and if they ask in the board exam, you need to write this point clearly by giving the proper example. Okay, to add or subtract numbers in scientific notation, okay, the power of 10 must be same. I'll show you. To add or subtract numbers in scientific notation, the power of 10 must be same. Okay, suppose I will give you one question. Say two numbers we need to add in scientific notation only. So suppose 39.5, okay, plus okay, this is simple question. I will give you 3.95. Okay, we need to add these two values. Okay, in scientific notation, if you want to express, the powers of 10 must be same. Okay, say here I will write 3.95 into 10 to the power of 3. Okay, 10 to the power of 3, and here it is. You should express this. 39.5 can be written as 3.95 into 10, right? Isn't it or not? 3.95 into 10 is 39.5 plus 3.95 into 10 to the power of 3. According to the rule, we need to add or subtract the numbers if and only if scientific notation, if the power of 10 is same. Okay, but the power of 10 is different. Here it is 1, here it is 3. Either you need to convert this 10 power 1 into 10 power 3, or into this 10 power 3 into 10 power 1. But according to the rules of scientific notation, better we'll do one thing. We'll express this into 10 to the power of we'll express this into 10 to the power of 1 format. Okay, 3.95 into 10 plus 395 by 100 into 1000. 10 power 3 is nothing but 1000. 2 cancel, right? 3.95 into 10, right? Into 10 plus 395 into 10. Here this basis, here the power of 10 is same, that is 1. Then we can directly add them. Okay, what's the value? 395 plus 3 is what? 395 plus 3 is 398. Okay, plus 0.95 is there here. Here since point is not there, you need to take as 395.00 plus 3.95. For your better understanding, I am writing clearly. 5 plus 3, 8 and 398.95. Okay. here another method. This is the first method, and second method, this one also you can do, that is 3.95 into 10 to the power of 1 plus 3.95 into 10 to the power of 3. This is there, right? You can express this into 10 to the power of 3 format. Here we expressed into 10 to the power of 1, say as a same power of 10. Here we are expressing into 10 to the power of 3. How we can do this operation? You just understand. We need to just, the simple task is, okay, I will leave a space here. This 3.95 into 10 to the into 10 it is there. Now to get 10 power 3, how much we need to multiply? We need to multiply with 100, by multiply and divide with 100. Okay, this kind of tricks you need to apply when solving the previous year questions. Sometimes you will be confusing where the decimal places goes towards left or right. Better you multiply and divide if you get any doubt. 1, 2, 3. Here we get 10 to the power of 3. That is 3.95 into 10 to the power of 3 by 100 plus this value. Okay. Now the decimal moves left side when it is divided, right? So 0.395. It becomes like this. Okay. 3.95 by 100. The decimal moves left side towards 2 places. So 1, 2. This is the value. Okay. Into 10 to the plus 3.95. We can take this common 10 power 3. This is into 10 power 3. The value will be same again. There is no change. Okay. Here you will get what? Okay, I'll write like this: 0.0395 plus 3.95. Okay, if you add 5, 9, 3 plus 5, 8, 9, 3 point, what we get? 3.9895 into 1000. It again becomes the same. Okay, sorry. 1 minute. 1, 2, okay. 0. Okay, 1 minute. Here we need to check it once. 10 power here into 10 we did not do. So that is 3989.5. This is the result. The same we are getting, right? Into 10 to the power of 3 is nothing but 1000. So 3.30. This moves 3 places right side. 1, 2, 3. So 0.5. Okay. 3989.5. In the two cases we are getting the same answer. Okay. But I prefer this method because if the 0 will come before the decimal point, it's difficult to calculate in your mind. Okay. Now just note this down. These are the rules which are also useful in your MCQs type models and also board level questions. Okay. Sometimes they will ask the example along with the rules. If they won't ask, suppose if they ask for 4 marks, write down the rule of addition and subtraction in scientific notation. If they ask for 4 marks, if you write only the definition, he may only give 1 or 1.5 mark. But if you explain with the example, you will be getting the full marks. Okay. According to your wish, you can prefer any of the two methods. Okay. Now let us see this. After significant figures, we will come to this. It's not that important. You generally know previously how to round off. But see this rules of significant figures. Okay. Basically, see, you don't need to understand the definition of significant figures. We need to only understand the rules of significant figures. These are all non-zero digits are significant. What does it mean? All non-zero digits are significant means except the number 0, from 1, 2, 3, 4, 5, 6, 7, 8 and 9, all the numbers are significant. All the non-zero digits are significant. Means except 0, all are significant. Okay. And in that also we have some exceptions. Now we cannot say by seeing the question every 0 is insignificant. No, not like that. But we have some exceptions. Okay. the zeros between two non-zero digits are significant. Study second, the zeros between two non-zero digits are significant. Suppose I will give you an example. Okay, I am erasing this. I will write big examples. Okay, take a screenshot if you don't, if you are not taken till now. Now I will give you an example, proper example for you. We are here, right? The zeros between the two non-zero digits are significant. Yeah. Let us take an example. 3.90056. This is just example, just see it. According to this, the zeros between two non-zero digits are significant. You may tell me, you may tell that all non-zero digits are significant. Why here zeros will be significant? Because according to the rule, the zeros which are present between the two non-zero digits, 9 and 5 are two non-zero digits, right? So these zeros between the two non-zero digits are significant. So count how many significant figures are there. Count the number of significant figures. Significant figures, or you can also say significant digits. Okay, significant digits. Okay, count the number of significant figures in this. All non-zero digits are significant. First you count that. How many are the non-zero digits? 1, 2, 3, 4. 4 plus the zeros which are lying between these two non-zero digits are significant according to the rule. So 1, 2. So 4 plus 2, 6 significant figures are there in this number. Okay. And again, I'll also tell you this. See, this is first example in this, and this is the second one. 6 significant figures. SF we can write as shortcut. So if I give this example, 0.05690105. Okay, let us say in this first of all, if any number is given, you count total number of non-zero digits first. So if it is an MCQ, you can directly eliminate one option. Okay, if you have this non-zero digits more than the significant figures in the question, in the MCQ value, you can eliminate that. I'll also tell you that. Don't worry. See, there is no rule that if you get 0 before the decimal point is significant. So the 0 before the decimal point is insignificant, means not significant, and this 0 is also not significant. If you see, the first significant figure in this is 5. We have the zeros will be significant if and only if the two two non-zero digits are there. Means two zeros when present between two non-zero digits other than 0, then they are significant. Unless they are not insignificant only. Okay. Here the zeros are there before the first significant digit. Okay. Here these two zeros are not significant because there is no number before this. Okay. So these are not significant. Here 1, 2, 3, and zeros between two non-zero digits are significant. So 3, 4, 5. 1, 2, 3, 4, 5. So 5 significant figures in this example. Okay. Now let us completely read this, and we will do another question. They are simple questions. They may be asked in your board exams, not competitive exams. Okay. The trailing zeros after decimal point are significant. Okay, the trailing zeros after decimal point are significant. Means, what are trailing zeros? I will show you. Trailing zeros. Okay. If you have a number like 3.9500. Okay. If you have a number like this, then if I ask how many number of significant figures are there, first count non-zero digits. How many are there? 1, 2, 3. 3 non-zero digits are there. And according to this rule, the trailing zeros after decimal point are significant. Means trailing zeros are nothing but the zeros which are present at the last. Means last doesn't mean that if I write 9000, these are not trailing zeros. The zeros which are present after the decimal point and after one non-zero digit are trailing zeros. Okay, I hope you understood this. The zeros which are present after the decimal point and if there is a non-zero digit before it, they are trailing zeros. Okay, you simply remember as the zeros after the decimal point are trailing zeros. In this, 3 non-zero digits are there, plus since these are trailing zeros are significant. So 1, 2, 3 plus 2, 5. Sorry, 3 plus 2, 5 significant figures in this. Okay, similarly I will give you one question. 395.756000000. Okay, tell me how many. Okay, I will make this complex somewhat, so you will be able to understand easily. Let us say this. Okay, tell me how many number of significant figures in this question. 0, I will read it out if it is not clear. 03950.56000000 in 6 zeros. 1, 2, 3, 4, 5, 6 here. Okay, see here this 0, since it is there is no non-zero digit before it, it's not significant, so insignificant. Let us don't count this. So first of all, count all the non-zero digits. 1, 2, 3, 4, 5. Okay, 5 plus it will be an easy thing. You need to make a habit like this. Okay, 1, 2, 3, 4, 5 plus the zeros between the two non-zero digits are significant. So 1, 2, 3, 4, 5, 6, 7. So how many zeros are significant here? This is non-zero between the non-zero digits. These are trailing zeros. How many trailing zeros? 1, 2, 3, 4, 5, 6. 6 plus 1, 7. So 5 plus 7 is 12 significant figures in this number. Okay, this is a high level question. You may get these type of questions in competitive exam, and he may also twist like 12 significant figures, round off to 2 significant figures if he asks. No, he may tell you like this. Okay, the answer is some x, and x is equals to and answer is like you need to express as x into 10 to the power of 3 plus 5. You may ask question like this, and x is nothing but number of significant figures. Okay, okay, right. 12 into 10 to the power of 3 is 1000. That is 12,000 plus 5. That is 12,005. And again he may twist like this 12,005. Round off this to 2 significant figures. You may ask 2 significant figures. Make this number such that there are only 2 significant figures. This is a JEE Mains level and a NEET level question. 2 significant figures means how many are there here? 1, 2, 3, 4, 5. Trailing zero, the zeros between 2 non-zero digits are significant. So 1, 2, 3, 4, 5. 5 significant figures. You need to convert this to 2 significant figures. How is it possible? Once think. Okay, 2 significant figures means if you remove this 5, what happens? These are not significant. Then it becomes 2 significant figures. But you need not change. You shouldn't change the units. You shouldn't change the place of the number. Means this is in 12,000s. Means in 10,000s place. You are getting my point. You shouldn't change from 10,000s to thousands or thousands to hundreds. Instead, you need to convert like 12,000. You should round off this to 2 significant figures as 12,000, not 1200. Because from 10,000 digit place, you shouldn't change to thousands place. You should see such that the place of the number won't change. Okay. This is a very high level question. If you don't understand, let us leave this for this stage. If you understand, well and good. If you don't understand, I'll however make another video based on solving. Okay, this very high level question. If you get solving this question, you will be easily doing units and dimensions chapter also, which is there in physics, and also this chemistry chapter, some basic concepts of chemistry. Okay, now this is the important thing. I already told that zeros before the decimal point are insignificant. Okay, this like this, zeros before the decimal point are insignificant, not significant. The exact numbers have infinitely many significant figures. What does exact numbers mean? Exact numbers like integers 2, 3, 5, 100. These are exact numbers. Means according to the situation you can write the points. For 100, how many after point? How many zeros you can write? You can write any number of. If I fill this board also, I have with from here to here, the zeros, it will not be completed. You can write any number of zeros according to situation. So that's why the exact numbers have infinitely many significant figures. Okay. And like here pi, it's a constant value. What's the value of pi? Pi is 3.14, okay, or 22/7. Okay, this 3.14 is an exact value. After 14 you can keep any number of zeros. In Boltzmann constant you will be having in this modern physics, and Planck's constant is universal gas constant. These are constants, all constants. You can write exact numbers along with all constants. All constants and exact numbers have infinitely many significant figures. Okay, just copy this down. Now rounding off, it's a very simple concept. See, suppose I have number like 5.96, you need to round off to 2 significant figures, 2 significant digits. What you will do? 2 means 5.96, you need to round off to 2 significant figures. Means you need to, this 6 which is greater than 5, right? 6 is greater than 5, so you need to add 1 to the preceding digit. So 5.9, 9 plus 1 is what? 10. So you need to write 6.0 is the correct answer for this. Okay. Similarly, 5.74. 5.74, you need to round off to 2 significant digits. Here again there are 1, 2, 3 significant digits. You need to round off to 2 significant digits. This 4 means there are 3 significant digits. See, 3 significant figures. This you need to convert to 2 significant figures. How is it possible? By rounding off this, right? Rounding off means you need to round off. We will suppose you got some 89 marks out of 100. You will tell somebody that you got 90 marks instead of 89. It's a simple word. You are rounding off 89 to 90 marks. Okay, this is a simple thing. If you want to understand, you comment me down. I'll make a separate short or some 5-10 minutes video based on rounding off, more rules. But it's not much important. The significant figures are much important. So let us see this for at this stage. Rules. If you want rules, you should better study from NCERT. You will be easily understanding. And listen to this first and then study there. Okay. This 5.74. This 4 is less than 5. I'll write the rule. 2 important rules in rounding off. You just write down. I'll write the rule. 2 or 3 rules. I'll write which are there in NCERT. Again, it will be trouble for you. I want you guys to just relax and study. I don't want to study this book, that book, that book. No, that won't work. Okay, studying only following only one lecture and one proper notes is enough. No need to go to NCERT also. If you go to that inorganic chemistry, there you need to go through NCERT. But studying line by line won't work for competitive exams. Okay, and see for NCERT also, for CBSE exams, the short notes is very easy to understand. If you ask even for 5-6 marks, you can easily elaborate. If you understand the concept, You can by own you can elaborate by giving the examples. No need to worry. Except in that inorganic chemistry, you need to remember some parts. There you need to see just to skim that too. In physical and organic, no need to touch ncert. That's it. Physical is no physical first. Organic leave it. Physical part you no need to touch textbook. No need. Just go understand formula, concept, leave it. That's it. First, just directly jump into the problem solving. Okay. Problems. What's the rule here is there are two rules. So okay, I'll write the rules, all the rules, no need to go to ncert again. Okay. If the rounding off okay, if the rounding off number, okay, just write this examples once. The concept is rounding off. It's very easy. You just see. Instead of this, I'll write the proper word. If the number to be dropped, is greater than 5, greater. Okay, I'll write in words again. Some people won't understand the greater than and less than. Even many of my friends also face difficulty. Even I till 9th class I didn't understand the greater than and less than. I used to solve easily all the problems, but this greater than and less than I used to confuse. Okay, it's a natural thing. If you see 9, 5, greater symbol is this. Okay, greater side. Where you have this opening curve, that is greater, and where you have this emerging intersecting part, it is less than. Okay, 9 greater than 5. 5 less than 7. Okay, this is if you want to express the number greater than as, then you need to express like this. If you want to tell some number less, you need to write like this. Okay. If I tell A is equals to 1, B is equals to 2, C is equals to 3, you need to write as C greater than B, 3 greater than 2 greater than 1. Okay, C greater than B greater than A, or A is less than B is less than C. If you want to express as greater symbol, means this is the descending order, this is the ascending order. See, this is just a small thing. This basic thing I want to explain. I want to explain from scratch. Okay. If the number to be dropped is greater than 5. Okay, if the number to be dropped is greater than 5. If the number to be dropped is greater than 5, then add the preceding digit. In the book it is given as raised, and instead of raised, then add the preceding digit by 1. It's a very, you need to understand a simple language. In the book it is given that if the number to be dropped is greater than 5, you need to raise the preceding digit by 1. Instead of raised, we can use the word add. You can then add the preceding digit by 1. Okay. Suppose, example, you have the number. If the number to be dropped is greater than 5, yeah, greater than 5 case. So okay, 8.97, and you need to round off to some. There are 3 significant digits, right? You need to round off to 2 significant figures. What you will do means the number to be dropped. The dropped means you are focusing that value by removing, by manipulating that value. You need to convert it. Okay, dropped means we are focusing on that value only, whether it is greater than 5, less than 5, or other thing. Okay, you need to this number is to be dropped is greater than 5. The number to be dropped is greater than 5. Since 7 is greater than 5, so then add the preceding digit by 1. So 5 is greater than 7 is greater than 5. So add the preceding digit by 1. What happens? 9 plus 1, 10. So 1 carry, again it will be 9.0. Some people what they do is, see, 8.97 is that right? They follow the rule perfectly. 7 means greater than 5. Okay, they will add 1. 9 plus 1 is 10. Okay, they'll write 8.0. Just think, from 8.97 how it goes to 8? No, it's not the logic. It goes to 9.0. That's small things. You will be understanding. I know you will be understanding the things which I tell you. Okay, now if the number to be dropped is less than 5, it is less than, okay, if the number to be dropped is less than 5, okay, then the preceding digit, then the preceding means what? Previous digit. Then the preceding, that is preceding digit is retained as such. Retained means remained as such. Means if the number to be dropped is less than 5, then the preceding digit is retained as such. Means example, you will understand these all things by seeing examples only. Suppose 8.94. Okay, this 4 is less than 5, right? So according to the rule, then if the number to be dropped is less than 5, then the preceding digit is retained as such. Means its preceding digit won't change. By means you may think you will write as it is 8.94. No. It remained as such means you should drop this. Means you need to write 8.90. Okay, I will give another example. 94.854. Okay, if you want to round up this, we will remove the point. You will confuse. 956. Okay, I'll write 9564. 9562. I'll write 9562. Okay, this is less than 5, so its previous digit is remained as such. So 9560. This is in this way you need to round off. Okay, right? Copy this. So see this. I am giving this you as a homework. You comment me down the answer. Okay. RO means round off. Okay. RO means round off. Okay, round off to, okay, I didn't write this right. Round off to 2 significant figures. Two significant figures. SF means significant figures, RO means round off. These are very basic rules. Okay, you may think I am taking more time on this, but investing time in this is very important. Okay, I'll tell you two rules. These are also important. Take a screenshot of this. Right? Take a screenshot of this. I'm rubbing this, okay, right? Okay. Now, the third rule which we are going to say is, if the number to be dropped is equal to 5. Here the real rounding off starts. Okay, if the number to be dropped is equals to 5, means we are rounding off the number we are rounding off means we are truncating the dropping the value of 5, and its preceding digit is odd. Okay, is odd. First case, second case we will see. If this is odd and second case is even. If this is odd, then its preceding digit, okay, I read this right, and its preceding digit is added or raised by 1. Means if the number to be dropped is equals to 5, then the preceding digit and this preceding digit is odd. For suppose if you have a number like 5.9 935, okay, if you want to drop the number 5, if the number to be dropped is 5, then its preceding digit, if it is odd, okay, then you need to raise this, add this by 1, you need to remove this 5. Okay, first of all, make the number which is there as 0. Remember that blindly. 5.9, 3 plus 1 is 4. This is the rounding off way. And if the number to be dropped is equals to 5 and its preceding digit is even, then it is remained as such. Remained as such means, see, if the number to be dropped is equals to 5, then the preceding digit is even, then the preceding digit is remained as such. It means here preceding digit. Similarly here also, it means preceding digit. I write here. Okay. Yeah, even. If it is even, like 5 point, we'll just change the number, 5.925. Okay, if the preceding digit, if the number of to be dropped is 5 and its preceding digit is even, then the number is retained as such. Means we need to make this as 0. If we are dropping any value, we need to make that as 0. Remember that. 5.90, so 5.92. That's it. Okay. This is the case. Okay. So, sorry, don't write 0. 5.92, it's enough. You need not, if the number to be dropped, the dropped number disappears. It will not become 0, it disappears. That is, you don't need to write. That's the rule. Again, in this you have some special case. That is, if the number is like 3.9596, yeah, and if you want, here in these cases the rounding of digit, ending digit is also 5, but if you want to round off here 1 2, okay, we don't need to take point, 3954. Okay, if they are 3954, 3954, if you have this value, if you want to round off till, if you have 4 significant digits, right, from 4 to 4 significant figures you need to convert to 2 significant figures, then you need to round off 5, here 5 only you need to round off. here, since the preceding digit is odd, okay, here you need not see odd. See, if the preceding digit, in this case, see, remember, just see this, we are converting 4 significant figures into 2 significant figures. Okay, if you are rounding off, you need to raise it by 1, it becomes 4000. No, not 4000, wait. Yeah, you need to, yeah, it's not possible to 2 significant, it's 3 significant figures you need to round off. You need to round off, see, 3954, if you want to round off to 2 significant figures, it's only possible when you make that 3, not 3, wait, here's one catch. You can only make 1 significant figure in this case, that is 4000. You will be only having 1 significant figure here, okay? This one. Because, see, 3954, here if you want, just think, don't go to in depth, just understand basically, just skim this, 3954, this is 5. If you round off, you need to round off to 1 significant figure. There are 4 significant figures. What you will only possible is, see, 3954 between 3000 and 4000, so 3900 and 4000, which is close, it is close to this. So you need to, it is 4000, not 3900. You will be again having 2 significant figures. This is the understanding. This is very high level. This is optional, I can say, because I didn't see any more number of questions on this. If in JEE Mains, if you have some 100 questions, if you have 1000 questions, I saw some 2 to 5 questions, 3 to 5 questions. That's it based on this. That is also not possible. Okay. Just you note better. You note down till this. Otherwise, you will confuse. It is mentioned in NCERT also, but it's very high level to understand. Now let us see the average atomic mass. What is this concept? Average atomic mass, right? I call this average atomic mass as it's a shortcut, right? AAM. It's a very easy shortcut. Average atomic mass is equals to, the average atomic mass is equals to sigma, means summation of percentage abundance into atomic mass per 100. It's a very important formula. Very important formula. Okay, I'll give star mark option there. Average atomic mass is equals to sigma summation of percentage abundance into atomic mass by 100. You need to remember this, however, it's important. Average atomic mass is equals to percentage abundance into atomic mass by 100. Is equals to, let us repeat 3 times. Average atomic mass is equals to sigma percentage abundance into atomic mass by 100. Average atomic mass is equals to sigma summation of percentage abundance into atomic mass by 100. Average atomic mass is equals to percent sigma summation of percentage abundance into atomic mass by 100. Okay. Similarly, it's average atomic mass. Here average molecular mass also there. Okay, it's similar formula. If you get one thing, you get another thing. Average molecular mass is equals to summation of sigma percentage abundance into molecular weight by 100. This is another formula. This is a very important formula. See this question. See, and did you understand? It's average atomic mass is equals to summation of this sigma. Sigma means adding all. Okay, sigma percentage abundance into atomic mass by 100. Okay, this example, this question, which came in JEE Mains. Okay, it came to JEE Mains, CBSE, okay, means board exam, and also this is the, I think it came or not, but okay, it's a very high level, it's easy. You can also take it for CBSE, but it's a PYQ of JEE Mains, PYQ of JEE Advanced, you believe it or not, it's a JEE Advanced PYQ. Or this easy question, formula based question directly came in advanced. See, PYQ of JEE means PYQ of JEE Advanced, that is IIT exam. Okay. The students who are preparing for NEET, it is also very useful for them. They will also get some formula based questions. Okay, example. Calculate the average atomic weight, that is average atomic mass of iron, if the abundance of isotopes of iron are 5%, 90% and 5% respectively. Study this again. Calculate the average atomic mass or average atomic weight of iron if the percentage abundance of isotopes is 1, 2, 3 isotopes is this much. Means first one thing is the strategy of solving this is, see, summation means or sum. Summation means sum, means adding all of them. Here what is formula? Average atomic mass. Calculate the average atomic mass of iron. So average atomic mass of iron, Fe means iron, okay, ferrum. Average atomic mass of iron, is equals to sigma, means summation. You need not write summation. Average atomic mass of iron is equals to percentage abundance. You need to correspondingly take this for this means average atomic percentage abundance into atomic mass is how much? It is mentioned in 54. Atomic mass by 100. Okay, plus again percentage abundance of this one 56, iron 56. Average atomic mass of iron, percentage abundance is percentage abundance into atomic mass by 56 is 56 into by 100 plus percentage abundance into atomic mass is 57 by 100. Do this. I will do this. Okay. It's 5 4s are 20. You carry 5 5s are 25 plus 27. Okay. 100 plus 90. So 0 here. 9 6 are 54. 5 carry. 9 5 is 45 plus 5. 50. Okay. Okay, by 100 plus 5 5 7 to 35. 3 carry 5 5 is 25 plus 3 28 by 100. Okay, and adding all of them, you get the answer by 100. You need to add here. Okay, you will add here as a rough 270 plus 5040 plus 285. We add 5. 7 plus 8 is 15 plus 4 18. 1 carry 1 plus 2 3 plus 2 5. 5595 by 5595 by 100 means 5595 by 100 means what? 1 2. Okay, 55.95 is the answer for this question. Just simple. You can do it in 1 minute. You need to solve more multiplication, division, multiplication and addition type of arithmetic operations. That's it. It's a very easy thing. You just copy it down. You can means I cannot say that exactly. It will be again coming in JEE means. Okay, they will ask this. If instead of 5%, he may ask 7%, 10%, 50%, like that. The total percentage is always 100. See this. So, take a screenshot. I'll give 5 seconds. Okay. Now, mole concept. Let us come to. Okay, I forgot to explain this. Okay, it's not much important. If you want, you can skip. It's a simple formula. Okay, what is vapor density of gaseous mixture? Vapor density. Okay, vapor density of gaseous mixture is equals to molecular weight of the molecular weight of the molecule by 2. Vapor density of gaseous mixture is equals to molecular weight by 2. Now you are getting my point. What is it? Vapor density of gaseous mixture is equals to molecular weight by 2. Okay, this is the formula. No need problems for that. No problem. No, not very important. So mole concept. This is very important. See, number of moles is always represented by letter small n. Right? Number of moles is represented by letter small n. In this mole concept, there is based on the number of moles, and we have 3 equations. Okay. We have 3 main formulae are okay. Based on this concept, number of moles, we have 3 main formulas. 3 main formulae. Okay. First one is number of moles. I already told you number of moles is represented by small n. Number of moles is equals to given mass by molar mass. First formula is number of moles is equals to given mass by molar mass. Number of moles is equals to given mass by molar mass. And second formula is number of moles is equals to given number of particles by Avogadro number. Number of moles is equals to number of particles by divided by Avogadro number. So n is equals to number of moles is equals to given number of particles capital by Avogadro number. So we can write this formula, number of moles, second formula in shortcut as number of moles n is equals to capital N by small n A. Then small n is equals to capital N by N A. Means number of moles is equals to number of particles by N A. Means Avogadro number. Okay, Avogadro number, we have fixed number. That is Avogadro number N A is equals to 6.023 into 10 to the power of 23. Okay. Then Avogadro number Na is equals to 6.023 into 10 to the power of 23. The second formula in Avogadro number you have is Na is equals to 6.023 into 10 to the power of 23. Repeat it. Avogadro number Na is equals to 6.023 into 10 to the power of 23. Okay, third formula is number of moles is equals to given volume of the gas at STP by 22.4 liters. Okay, it's liters. L means liter. Okay, number of moles, third formula is number of moles is equals to given volume of gas at STP by 22.4 liters. Okay. Okay, number of moles is equals to given volume of gas by 22.4 liters. Here, given volume of gas at STP in liters. The numerator and denominator should be in liters. Okay, I am getting my point. Okay, the point is that. Okay, the point is that number of moles, third formula. It's very important. You will be frequently using. You should do in your mind. Number of moles is equals to given number of particles, given volume of the gas at STP by 22.4 liters. Here STP. You may ask, what is STP? STP means standard temperature and pressure. STP means standard temperature and pressure. Okay, STP means standard temperature and pressure. Standard temperature and pressure. Okay, you need not worry about this. Standard temperature is 25 degrees centigrade Celsius, and pressure is atmospheric pressure, that is 1 atm. So STP means standard temperature and pressure. No need to worry about this, but you need to mention as at the rate of STP. Okay. Number of moles is equals to given number of this form, same form. Number of moles is equals to given number of particles by Avogadro number. Small n is equals to capital N by Na. Third formula is given number of moles is equals to given volume at STP of the gas by 22.4 liters. Okay. Well, now this is also important. Percentage of an element in the compound. Okay. Percentage of an element in the compound. Okay, first of all, percentage by weight of the element. How much percent of the element is there in the compound? Percentage of an element in the compound means how much percent of the element is there in the compound. Percentage by weight is equals to weight of the element in the given compound, weight of the element in the given compound by molecular weight of the compound into 100. Okay, you are getting my point. The percentage of an element in the compound is percentage by weight is equals to given mass of the element in the compound, weight of the element in the given compound by molecular weight into of the compound into 100. You just note down this. I love this. If I tell you, if I give you the example of CaCO3, what is CaCO3? It's calcium carbonate. CaCO3 is calcium carbonate. Tell percentage of calcium in CaCO3. What did I ask? Tell the percentage of the element of calcium in CaCO3. Percentage of formula is percentage of element. This percentage of calcium in CaCO3. Percentage of calcium is equals to given weight of the element. How much it is there? So total weight is of element. Total weight of molecule. Total weight of molecule is atomic mass of calcium is 40 plus atomic weight of carbon is 12. Yeah, atomic mass of oxygen is atomic number is 8. Atomic mass 16. 63 is a 40. Okay. 40 by total mass is 40 plus 12, 52 plus 48. That is 100. Okay. Percentage of calcium is equals to weight of the element in the compound. How many atoms are there? Only one atom. So percentage of the calcium is equals to weight of calcium in the compound by total weight into 100. How much percentage is there? It's 40%. Okay. Like this you need to do. And again I'll give another question. If I tell in calcium, in sodium carbonate, how much percentage of sodium is there? Okay, then percentage of sodium is equals to mass, total mass of the compound is, see, atomic number of sodium is, neon, after that sodium, right? Atomic number of sodium is 11. So, but atomic mass is 23. So, two atoms are there. So, 2 into 23 is 46, right? 46 AMU of sodium is there. 46 by total weight is what? 46 plus carbon is 12 plus oxygen is 316 is 48. Okay, 48 plus 12 is 60 plus 46 is 106. 106 into 100. You do this calculation. Okay, I will do 2 5 is 2 3 is 2 2 is 2 3 is. Okay, approximately if I do 2300 by 53. Okay, I will calculate 53. 53 2300 or 53 into 4 5 3 4 3 is 1 4 5 is 20 212 is 4 times it's 18, right? Then it's 18. 180 means we are taking, okay, we will take 3 times. So 53 into 3, it is 51, 59. So this 21, right? 21, and we need to take point here. So 4 approximately 43.4% is the sodium in this compound. Like this we need to calculate. Okay, like this we need to calculate. The answer is, I written right, 43.4. If I tell you correctly, you have 53 into 3, 3 is 9, 3 is 5 is 15. So actually we need to take 43.3 is 159 means 51. Again, yeah, approximately 43.39. Means we can take it as 43.39 is the correct answer. But if you want to round off in your board exam, you can write as 43.4%. But in integer type questions in JEE Mains, you need to write it as 43.39. You may tell if answer is equals to, if answer is equals to, you may not say. If answer is 40, if answer is A, then A into, if answer is A, if answer is A into 10 to the power of, yeah, A into 10, round of A, then A is what? Okay, A is what? In that case, means we got 43, means basically what I am telling you is, if percentage of sodium is A into 10 to the power, A into 10 to the power of 1 means 10, round of A is the answer. Round of A is the answer, which we rounded off value of A is the answer. So here 43.39 can be written as 4.399 into 10. Okay, you need to write the value by rounding off in integer type. Okay, you need to tell any integer. Then if 4.3 is close to 4, so you need to write as 04.00, like this you need to write. Not, if you write 4 also, sometimes it will be mistake, if there is any error. So we better to write 04.00. Like this the questions will be. In calculation part, if you have any doubt, I'll just zoom the video. Better you do the calculation as per your understanding. See, if it is not clear, you just comment me down. Yeah, this is just calculation part. That's it. I zoom till maximum how much it is there. Yeah, that's it for this part. Now let us in the next part we'll complete this empirical formula, molecular formula, molarity, molality, normality and stoichiometry. Okay, thank you.